Hello classes and students. Today's learning target: I can analyze molecular compounds using Vsepr theory. In this video we are mainly going to be focusing on the first two parts of this learning target. So we're going to determine the shape of the molecule based on Vsepr theory and determine if a compound has single, double, or a triple bond. The last three parts we're going to look more in class. So what is Vsepr? What Vsepr stands for, it stands for valence shell electron pair repulsion. So it helps us predict the geometrical shape of compounds. Remember that electrons have a negative charge. And negative charge, they repel each other. So the electrons in the outer energy level, the valence electrons, when we have a compound, they interact with one another and they push each other away. So they repel each other, and that helps us predict the geometry of the molecule. Here we go. Let's do some examples, but before we do the examples, we got to talk about the rules. So the first thing we want to do is draw the Lewis structure for the molecule. How do we do that? Well, we can draw the Lewis structure for each atom. And unpaired electrons in the atom, they're going to want to bond, because remember the octet rule, that atoms want to have 8 electrons, and they're going to do whatever it takes to get 8 electrons to form a bond. So draw the Lewis dot diagram for each atom, connect the unpaired electrons to represent a bond, and then you're going to make everyone happy. Make everyone have 8 electrons. So let's do some examples. The first example we're going to do is nitrogen trifluoride, so NF3. Now when you're talking about valence electrons, remember that nitrogen has 5 valence electrons and fluorine has 7. 5 and 7 is the number of valence electrons. Mole just tried to attack me. But we have 3 fluorines, so we got to do that 7 times 3. That gives us 21 valence electrons from fluorine, 5 from nitrogen, add those up, 26 valence electrons. So we know after we make this compound, there should be 26 valence electrons on the Lewis structure. Now, for the actual structure. Normally, in most cases, the first element is going to be our steric, so the one that's in the center. So we're going to draw nitrogen in the middle. Nitrogen has 5 valence electrons, so I'm going to put 5 electrons, 5 dots around nitrogen. Remember, they want to be apart, and then they go back and double each other up. So there's my nitrogen Lewis structure. Notice how we have 3 unpaired electrons. Well, they want to be paired, so you're going to have to use your intuition when you're building molecules. I'm probably going to have a fluorine here, and a fluorine here. Now, each fluorine has 7, so I'm going to add 7 dots to each fluorine. Notice how I'm strategically placing the lone electron closer to nitrogen. This will make sense in just a minute. So we have our valence electrons. Now we're going to connect the unpaired electrons. So this is an unpaired. It's going to connect with nitrogen to form an unpaired. These 2 electrons are going to form a pair, creating a bond. And these 2 are going to connect, forming a bond. Now let's make sure that we have the correct number of valence electrons. So we should have 26. Now we can count. 1, 2, 3, 4, 5, 6. Lines count as 2 because a bond is between 2 electrons. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. And I put an extra dot right there just now. So we have 26 valence electrons, so we're good. Now we got to make sure everyone's happy. And what I mean by happy is they follow the octet rule. So everyone wants to have 8 valence electrons. So let's check and make sure everyone does. So this has 1, 2, 3, 4, 5, 6. Remember, bonds count as 2 because they're sharing electrons. So 7, 8. So yeah, this Florian's happy. And this one, 1, 2, 3, 4, 5, 6, 7, 8. So happy, happy. 1, 2, 3, 4, 5, 6, 7, 8. Happy. Nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. Happy. So, everyone's happy. We are good to go. Let's do one more example that's a little bit tougher. Oops. Oh, I gotta erase it. Alright, for this example, I want to do sulfur trioxide. So let's count how many valence electrons we have. Sulfur has 6, oxygen has 6, but there's 3. So that gives us 18. 6 plus 18 is 24 valence electrons. So we should have 24 valence electrons at the end of this. Now the first element normally always goes in the middle, so sulfur. So I'm going to put sulfur in the middle with 6 dots. Now it doesn't quite matter where we put those 6 dots. You can do it however you'd like. I do it this way just for no reason. Next we have 3 oxygens. So I'm going to put an oxygen here, and an oxygen here. Each oxygen brings 6 electrons to the table. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Here's Miss Brown with an announcement.
Madison Ponder to the front of the building, your ride is waiting. Madison Ponder to the front of the building, your ride is waiting.
Alright, as Madison's going to the front office, because of her ride, we are going to connect the unpaired electrons. So we have an unpaired electron here, we're going to connect it there. Create a bond. We have an unpaired here, connect it there to form a bond. Well, we have oxygen at the very bottom that's all by itself. We know that oxygen is going to bond with this sulfur. We're never going to have a bond that forms a triangle. We don't want that. Not going to happen. So, I'm just going to take this electron, and even though it's paired already, I'm just going to have a bond right there. So now let's go through, make sure we have 24 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I have 24 electrons, so I'm good on that. Now let's see if everyone's happy. This oxygen, 1, 2, 3, 4, 5, 6, 7. Uh-oh. Unhappy. This sulfur, 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh. Unhappy. Because it has 9. It wants 8. It's got too many. This oxygen, 1, 2, 3, 4, 5, 6, 7. Unhappy. This oxygen, 1, 2, 3, 4, 5, 6, 7. Unhappy. So right now, everything's unhappy.
Michelle Smith, could you please report to room 215? Michelle Smith, please report to room 215.
So we got to make things happy. And the way we make things happy is we manipulate the electrons. So we're going to add some double bonds. We're going to move some electrons so that everyone's happy. Now what I've noticed is I have this electron is a lone pair. I've got that electron right there. So what I can do is make this a bond. Now I'm going to erase this and redraw it so it's a little bit neater, but that's the idea. Let's see if I can do this neatly. So we're creating a double bond here. Okay. Now let's see if we're happy. We just made this oxygen happy. So 1, 2, 3, 4, 5, 6, 7, 8. So this this oxygen's happy. This sulfur, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that sulfur has 10, not happy. It needs to get rid of 2. And these oxygens, well, how many do they want? They have 7, they want 8, so they want 1 more. Look at the very top of sulfur. We have a lone pair, 2 electrons by themselves. Let's erase those and distribute that to each electron. Now let's check to make sure everyone's happy. 1, 2, 3, 4, 5, 6, 7, 8. This guy's happy. Sulfur, 1, 2, 3, 4, 5, 6, 7, 8. Happy. Oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Happy. This oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Happy. Everyone's happy, so we're done. And that is Vsepr. When we get in class, we're going to be talking about polarity, and we're going to be talking about the actual geometry of these molecules.